Okay, hi. This is a video called Page 22, 23, and it's computing the inverse of a Fourier transform matrix, F sub n. And it turns out to be easy, and easy means theta of n squared, not theta of n cubed. So to compute the inverse of a matrix in general, in life, an n by n matrix takes n cubed work. And we're going to see that because of the special form of the coefficient matrix F sub n, that this is much easier. You basically you just have to do a little bit of work for each element in the matrix and you get the inverse. So let's use n, just to keep it small so we don't go crazy, let's use n equal 4. And let's use z sub 5, and let's use alpha equal to 2. Okay, so before we, so the Fourier transform matrix F sub 4 then, if we just do what we would do all the time, so it's alpha 0, are those four guys, and then so this spot here is alpha is just alpha to the 1, so that's 2. And then on this row we multiply by 2. So if we multiply by 2, we get 4. We multiply by 2 again. 4 times 2 is 8, which is 3. Okay, and then because the matrix is symmetric, the same, or for whatever reason you want to think about, the same thing down the column. And now in this row, we're multiplying by 4. So 4 times 4 is 16, which is 1, and 1 times 4 is 4. And on this column, this row across, we're multiplying by 3. So this is 9. The next guy is 9, which is in fact 4, and then 3 times 4 is 12, which is 2. So that's our matrix. Now I'm going to tidy it up and get rid of these underlines, just because I can. Oops, I destroyed the bottom of my 3. Okay, so that's, and our goal here is to get F sub 4 inverse. And the recipe, which we'll prove works in a different way than I did in the notes actually, is just to go through and do, you can do the element-wise inverse. So what does this mean? It means to get the guy that goes, so first of all, what the inverse of 1 is just 1, that everyone seems to buy. So the first interesting thing is what goes here? Well, it's just the inverse of this. So the inverse of 2, of this number 2 in Z5, you're looking for the number that you multiply so 2 by in order to get 1. And with a little thought, we figure out that that's 3. So this value here is 3. And what's the inverse of 4? What do you multiply 4 by to get 1? And the answer is 4 times 4 is 16. So in fact, 4 is its own inverse. So we put 4 there. And here, what do we multiply 3 by to get 1? Well, of course, it's 2. Because we know that 2 times 3 is 1. Okay, so in this very simple world, the inverses are quite easy. And so here on this row, we just get the same thing, and then 2, 4, 3. So in Z5, and the F sub 4 is really simple. And the check, if you do row times a column, rows times the columns. So I'm going to actually do all of these laboriously because it's so fun. Okay, so first I'm going to do this row, or I'll do a bunch of them. This row times this column. So in the usual way, if we hold our one finger here and point to here, 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 and at the same time we point to here, 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 and we multiply, so it's 1 plus 1 plus 1 plus 1, which is obviously, let's do the simplified answer check over here. So 1 plus 1 plus 1 plus 1 is 4. Not good if we're trying to get the identity. We'll talk about that in a minute. Okay, then I take this row times the second column. So that gives me 1 plus 3 plus 4 plus 2. So interestingly, when you add up all the numbers in Z5, except for 0, 1 plus 3 plus 4 plus 2 is 4 plus 4 plus 2 is 10, is 0. And then the first row times this column gives me 1 plus 4 plus 1 plus 4, which is also 0. And the first row times the last column obviously gives 1 plus 2 plus 3 plus 4, which is also 0. So that seems kind of too easy. And obviously we're going to easily get this guy. This row times this column is the same one we just computed. Ooh, now here's an interesting one. So this second row times the second column, actually column row 0, 1 times column 1, gives us 1, right? 1, so it's the 1 times the 1 is 1, plus 2 times 3 is 6, but that's 1 in Z5. And then we get 4 times 4 is also 1. And then we get 3 times 2 is 6, which is also 1. So we end up with 4 again. Anyway, so you can continue in this same way, and you get zeros everywhere, except on the diagonal. So this proves that this gives us it almost gives it the right thing. So it actually gives us 4 times, so we really need to take 1/4 times F4. But we won't worry about that, because if we were doing anything with this, we would have to, but we don't have to. So now I want to take a moment to see why this is so, and maybe review a little bit of what we did on the previous video. So on the next page, okay, so let's write out what F4 really is. F4 is actually alpha 0, alpha 0, alpha 0. I'm having a little bit of flashback to the last video, which was so painful. So always F4, no matter what world we're in, is alpha 1, alpha 2, alpha 3, alpha squared, alpha 4th, alpha 6th. But okay, let's see, I've got to think for a minute. Yeah, I'm going to just go ahead and drop it back. So alpha 6 is actually alpha to the 1. And then here we multiply by alpha cubed. Alpha cubed times alpha cubed is alpha 6, which is alpha 1. And alpha 1 times alpha cubed is alpha 4. So that's what the coefficient matrix looks like, F4. And so the interesting thing to see, what is actually F4 inverse? What I'm calling it. So it's almost the inverse. So if we look at it this way, the inverse, so these guys are just the same, of course, but let's focus on this. What could we multiply alpha to the 1 by to get 1? And the answer is, this world, we know that alpha to the 4th is equal to 1. So we obviously want alpha cubed, because 1 alpha times 3 alphas gives me 4 alphas. So this is actually alpha cubed. And similarly, the thing we multiply alpha squared by is alpha cubed, and alpha cubed is alpha squared. Wait a minute. Alpha cubed, what? Oh, sorry, alpha squared would be another alpha squared, and alpha cubed would be alpha to the 1. And similarly, we'll get alpha squared, alpha to the 1, alpha cubed, alpha to the 1, alpha to the 3, alpha to the 0. Okay, and if we check what these are, let's do alpha equals like we did on the last one. So if alpha is 2, then alpha 0 is 1, alpha to the 1 is 2, alpha to the 2 is 4, alpha 3 is 8, which is 3, and that's all we need. And then alpha to the 4th is, of course, 1, because it's 6, which is 1. Okay, so this matrix actually does turn out to be, so alpha cubed is actually 3, alpha squared is 4, and alpha 1 is 2, and so on. Alpha squared is 4, alpha to the 1 is 2, alpha cubed is 3, and then alpha to the 1 is 2, alpha cubed is 3, and alpha 0 is 1. So that should compare, if we look back to the previous guy, well, it's also just another way to say, get the inverse of each element. So that doesn't prove that this works, but it is kind of interesting that it's a different way to look at getting the inverse. Maybe not a good one, but and it's also kind of interesting if you take a row times a column here. For example, if we take this row, say, times, say, the second column, or let's do it times the third one. So row 3 times column 3, dotted with column 3, so it's equal to alpha to the 0 times alpha to the 0, so that's 1, or alpha to the 0 if you want it that way. And then alpha 2 times alpha 2 is alpha to the 4th, and then alpha to the 4th times alpha alpha to the 1 is alpha, what? Uh-oh, something's out of whack. Alpha to the 5th, is that right? And then alpha to the 1 times alpha cubed. Did I do something wrong here? I think I did. I want all these to be 1. So I think when I was doing this, oh yeah, alpha squared times alpha squared is alpha to the 4th, which is actually alpha to the 0. So here when we take alpha to the 4th times alpha 0, we get alpha to the 4th. So you can sort of see why you get 1 plus 1 plus 1 plus 1 when we did it. And that's a general thing. The more interesting thing is if we take row 3 dotted with column 2, that's alpha to the 0, alpha squared, alpha to the 4th, alpha to the 1, that little row matrix, times this column matrix, 1 alpha cubed, alpha squared, alpha to the 1. You get alpha to the 0 plus alpha to the 5th, which is alpha to the 1, right? And alpha to the 4th times alpha squared, that's just alpha to the 2, and alpha to the 1 times alpha to the 1. Oops, I'm doing something wrong. We know that alpha 4th equals 1. Huh. Anyway, if you do this correctly, you can see you get a power series, a geometric series rather. And in the pre-reading notes somewhere around page 23, I actually prove that fact in all its gory detail. But anyway, this, if you go back to the previous page where we just you just take the inverse of each guy in place is the main idea you need for the test. So thanks.